That's different. The X stands for the input, and the Y stands for the output. Okay? Input and output. Okay? And then, so if we was to put up a list of ordered pairs, like we would say 0, 1. If I put in a 1, I get 2. If I put in a 2, I get 3. This is my, blue is the input. And then if I looked at that, what would the pattern be? What's the pattern that's going on there, Mr. Gabriel?
Y is always going to be one number greater than X.
Okay, and so technically you could say that the formula was X plus 1. Do you agree?
Yes.
Okay. Does that not look like a formula that we've been dealing with in the last month? And what formula would we call that? We call that what formula? Who said, somebody said it over here. Was that you? Olivia. Okay, Olivia, say it louder. It's the slope-intercept formula. We've been using it, we just didn't ever call it that. But that's really what we're dealing with again. Okay, I hate to tell you, it's not over with, it's not gone. Another way of list, and so like, you're gonna see some things today that look like this, and I know that looks kind of weird, but.
Those are big
Um,
building boards.
And in here, we're gonna 2, 3, 4, and then it's gonna say, well, we put this in and we're gonna get this out, 6, 9, 12. You're gonna see some pictures that look like this. This is called a mapping diagram. Because you're gonna be asked to do it. Or to interpret it. Okay? Nothing more than a mapping diagram. When we talk about it, this is the input, so this is our which value. Which value would this be?
X.
The X value, and this is my output. Technically my X and Y. If I was looking at that, can I now write the ordered pairs?
Yes.
Do you have a question, sir?
I have the
You have the, well, I haven't asked an answer, other than you're anticipating the answer, okay, so hang tight. So if I wanted to write the ordered pairs that are being displayed on this mapping diagram, what am I gonna write? What do I write here? Matthew?
3.
Give me another ordered pair that you're seeing on this mapping diagram. Mr. Zane?
4, 12.
Zane's gonna go over here to 412, that doesn't surprise me. Thinks out of the sight of the box. Jillian? 2, 6. What else do I have there? Reagan? 3, 9, okay? Okay, that's all there is to it. Now, if I was to ask you, and Zane, do me a favor, turn around, okay? If I was to ask you, what is the pattern in this? What pattern do you see is occurring there, Mr. Caden?
3x equals y.
3x equals y. Okay, let's see if he's correct. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. Very good. Okay, he has the pattern. So now I've got ordered pairs, I've got a mapping diagram. Okay, what if I give you another one? Do you have your whiteboards? Get them out.
Ooh. We see.
I want you to list the ordered pairs for this mapping diagram. Everybody's listing them. Make sure that we can just list the ordered pairs. Not a hard concept to do, but And everybody at the beginning of this year was given a whiteboard, and I see a lot of kids without whiteboards. Where are they? Where are the whiteboards? Okay, those whiteboards are to come to math class. So bring them with you. Javen, give me the first ordered pair that you see there. What's the first ordered pair? 0, 12. What's the next ordered pair that you see, Darton? 2, 10. What do you see there, Sophia? 4, 8. And what is the last ordered pair on this mapping diagram? Page? 6, 6, okay? What's the pattern? What is the pattern in this mapping diagram, Tanner?
Negative x plus 12.
Negative x plus 12 equals y. Negative x. Negative 2 plus 12. Okay? Somebody says what? Does anybody not know where that's coming from? Okay, let's look at it. If x is 0, 0 plus 12 is 12. Negative 2 plus 12, what do you get? 10. Negative 4 plus 12 is 8. Negative 6 plus 12 is 6. Do you see where it's coming from now? All right? Okay. Oh, go back to that one. Oh, we already got the pattern. Okay, here we go. So what do you think about just being able to identify the ordered pairs or what the input and the output would be? Because that's really what we're identifying. What is the input? What is the output? And then that part of it. Fist to 5. Where are you at on that? Okay. That part's pretty easy. Now, finding the pattern sometimes can be a little bit more difficult. Okay. But that's one of those things on these, like this first one, this one was pretty easy. And it's really kind of going up slowly. Well, 3, 6, 9, 12. It's not real fast. But you look at the X and you find out where did the Y come from. This one took a little bit longer. Had to go back and do some, probably some guess and check to figure out where that came from. Okay? And the reason why it made it difficult was because you had to look, well, 0 plus 12 is 12, but you can't add 12 to 2 and get 10. So how would you get that? And so that's kind of where you have to do some trial and error. We can get that. The other thing that we said we had to be able to determine today was whether a relationship is called a function or not. Well, first of all, we have to know what is meant when we hear the word function. How do we know if something is a function? A relation that pairs each input and output. Each input is paired with exactly one output. Okay? A function is a relation where each input is paired with only one output. Okay? So when I go back to what we were working on, what we've practiced with already, if we look at this one, would negative x plus 12 equals y be a function? It's going to be. Every input has exactly one output and only one output for it. That means it's a relation. okay? Or that means it's a function. That's what our ultimate goal is to find out. So let's look at, just by knowing what a function is, what if I give you this one? And of course, they have those cute little drawings, but, you know. Is that a function? How many of you think, give me thumbs up if you think it is a function, thumbs down if you think it is not. And you gotta be able to defend it. Okay? You gotta be able to defend it. Zane, you say that yes, it is a function. Why do you say that?
Because every input only has one output. It didn't say that it couldn't, there could be two inputs with the same output.
Right.
It didn't say that.
Each one of these is paired up with only one output. And that's what it says. It's got to be paired with only one output. It doesn't say that two inputs couldn't have the same output. This is a function. Yes, it is. Yes, ma'am.
It's like whenever you bracket, it has to vertical line this, and so if there's two line numbers, it doesn't, it can go like that. But it will.
A function will pass a vertical line test. You're correct. Okay, well let's look at this. Here's another one. Let's do another sample here. What if I give you -2, -1, 0, 1, 2. And over here, this is my input. And over here is my output, and I have 3, 4, 5, 6, 7. This is the output here. This is its output. So this one's a function. Look at the second one. Is the second one a function? No, I didn't.
I'm serious.
Is the second one a function? If you think it is a function, give me thumbs up. If you think it is not a function, thumbs down.
Give me a 5.
Kennedy, you may need to stand up to stay awake if that's what it takes, okay, babe? You look like you're having a hard time, okay, sweetie? Do you have a headache? Okay, have you taken anything for it, honey? Do you need to go down to the office and get some? You're good? All right. You might check for me and make sure she's not running fever, because that's kind of, yeah, you know what I mean? Okay. All right, is it a function? Yes or no? Thumbs up or thumbs down? Show down. Let me see. It is not a function. Why? Why is it not a function? Aaron?
Because 0 has both 5 and 6 has their output.
Yeah, look at 0 by itself. The output with the 0 is a 5 and 6. Every input has to have only one output. 0 has 2. That's what threw it off right there.
I see it now.
Okay? 0 has 2 outputs. If it's got 2 outputs, it is not a function. Okay? Let's try, I want you to try one more. Because this is pretty much all you're doing today. This is it. Give me one more. Let's try. Let's try for my input. I'm going to go with -1/2 and 1/3. Outputs. Is it a function or not? Thumbs up or thumbs down? slow down.
No.
Matthew. Matthew says no, it is not a function. Why not?
Because there's two
No, there's two.
outputs for each.
Yeah, what's your ordered pairs in this table? Tell me one of the ordered pairs that you're seeing right there. Trenton, give me one.
Negative 1 and 2.
Negative 1/2 and 2. The second ordered pair there is, what's the second ordered pair, Landon? I got negative 1/2 and 2. What's my second ordered pair? Negative 1/2 and 4. What's my third one? Give me the third one. Darton, give me it.
1/3 and 7.
1/3 and 7. And the final one is what, Zane? 139. The minute that you see that the x value has more than one output, you know it's not a function. So it is not, no function. What about last one? Function or not a function? Thumbs up, function, thumbs down, not. There's no calculating to this. You just have to look at the numbers. This is one of those 10-second answers on Quiz Bowl. You should be able to tell me in 10 seconds, is this a function or not?
This should take like 5 seconds.
What's it gonna be, Miss Zoe?
Function.
It is a function. You are absolutely correct. That's what you're doing today. How do you feel about fist of 5? Tell me how you feel about it. Yeah, that's kind of what I'm thinking. It's pretty easy. Your assignment today. There you go. Textbook, page 246, 247, 2 through 16 even, and then 19 through 22. That's it. Okay? It is not a long assignment. You also have time right now to get it done.